Okay, when you looking at the our virtual class dashboard in financial technology and data analytics, sorry, I'm mistake for upload the class of recordings, but it will be uploaded later for the 6th May and 13th of May. And for today, I just uploaded for the materials. Today we are learning about the relationships between your variables. So the focus or the topic of the data analytics for today is talking about the regressions analysis. And I give you new submissions in here for upload your exercises as for the befores like the before of exercises. I give you a day of a timing, a day of a day for make some exercising with the relationships because it's a new variables, and you can upload until the tomorrow, the day off, and you can say that maybe it's more challenging than the inference. Last week we talking about the inference that we need to cover about the correlations and the effects between one and two of variables. So for today, we are continuing the materials. It's quite for the relationships in a business analytics and data and the decisions making. I hope the slide is well prepared for you. Is anyone can see the screen? Can you see the screen about the materials for the relationships?
Yes, sir.
Okay, thank you. Okay, today we are continuing our matery in data analytics, and our subtopic for today is about the regressions analysis and how estimate the relationships between variables. Okay, no problem here since even I think that's the better if you can hear my voice or you can interact with the chat rooms. That is preferables. Then we are offering about the quality of your camera. Okay, next to continue about the materials. Today we are talking about the regressions analysis. It's the one of the powerful analytical tools to predicts or to study about the relationships between the variables. The variable is maybe more than one or two the variables that you will be regress or you will be connected to create some predictions and understands how they are operates and making some connections and also with the predictions. But before we continue, what kind of the analysis, we need to know that there are two kind of the basic types with your data. The data is uh could be yep, it could be presenting as the cross-sectional data or in a time series of data. In the cross-sectional sessions, it means that you need to gather all of the data and you take it in the same period of the time. You getting all of the data in the populations or in a samples, but you take all of the data in the same period of times. For examples, you take all of the provincials data in your country, Philippines, only in the one time, might be into 20 and 20 or 20 and 21. In another ones, we need to learn about the time series of data. As the name of the time series of data, it's conclude that you need more of variables that will be observed mostly in the another point of the time. It should be correlate with the another years or another of time indicators. The time indicator, it could be in a yearly or annually, or you can make some differentiations between the monthly or weekly periods in the time series of data. So it should be more complicated than the cross-sectional data because the time series of data have a time in variations. As we know that maybe we have the difference analysis in a different year. So, while we are predicting the correlations or the relationships between variables, it consists of two kind of the variables. The number one is called the dependence variables, or a single variables that we try to explain or we try to predict. The dependent variables have the another terms. We also called about the responsible variables or the target variables. This kind of variables is one of the variables that should be predicted with another or maybe lots of factorials. The factorials called the independence variables or explanatory variables. Sometimes we also use about the name about the predictor variables because with these variables we can predict, we can explain, and also they are not depending with the another of variables. But the dependent variable or target variable, it's will be connected or having a relationships, a full relationships with the independent or explanatory variables. So in the kind of regressions or in the relationship of variables, we have we also have two kind of analysis. The first one is a simple regressions, and the other one is about multiple regressions. As the name, a simple regressions, we only predict with a one explanatory variables. It's just only once explanatory. And the another ones is about the multiples regressions if we want to predict more than one explanatory variables. So in this case, okay, we in a simple variables, we only have one of explaining variables or explanatory variables, and the multiple variable is more than one of explanatory variables. So it should be make some differences between the simple regressions and a multiple regressions. And the kind of regression is also presenting in a different type. Sometimes we are in the made of straight line like this one, or in line with the relationships between the variables, and another ones we have the nonlinear or curved relationships. The relationships like curved relationships or nonlinear, it's differences between the another variables. We will talk in the later of slides before we are continuing about the regressions analysis. Okay. We need to make scatter plots or graphing these relationships between the one's variables into another variables. In the mathematical functions, we also say there is two plots of variables in the x positions and in a y positions. It's should be difference in the presentings, and we can analyze with the graphicals or the scatter plot of this kind of variables. For examples, if we have the data about the overhead of costs, like this ones, we have the three kind of variables. The three kind of variable is consists of the machine's hours as the first variables. The production runs is the second variables, and the overhead cost is for the third variables. As we learned, we have dependent variables and independent variables. Okay, the dependent variables is a variables that should be depend with another factors. In this case, let's say that the overheads or number three is independent variables. And the another ones for the machines hour and the kind of the productions runs is the independence of variable or explanatory variables. It's number one and number two. So in this case, we can make a two kind of scatter plots between the one of the dependence for overheads and machines hour, and also for overhead and the productions runs. These two kind of scatter plots will be presenting before we continue with relationships predictions. I repeat again, before we continuing with the relationship predictions, we need to draw about the scatter plots between the variables. In this case, we have two kind of plots between the overhead as the dependent variables and machines hour as the first plot. And the second plot is for overhead as the dependence with the productions runs for independence variables. So when we're looking at the analysis, we have two kind of scatter plots. The first plot is between the overheads and the machines hour, this one. The overhead is in the y-axis and machine hours in the x-axis. Similar with that, we have the overhead here as the y-axis and productions run as for the x-axis. So in this case, we can predict that we have the relationships of predictions. In the kind of these plots, we can conclude that maybe they are in a linear relationships. How do you know? Because we can create with some linear analysis here with these patterns. It's similar to these ones. So when we following the patterns, we know that there is a linear or non-linear patterns. Okay. In this case, we found that between the overhead and machine hours and overhead and production runs, they are creating graph or make a scatter plot in a linear positions. Any questions so far? No? Okay. Let's continue about the overhead costs. Okay, thank you for responding with the chat room, Oliver. Okay. Sometimes we found about the difference patterns. It's not in a linear graphicals or in a linear charts. We found in non-linear graphicals like these ones. We have the inflations or in variations between the time series of overheads. But we can conclude with the another of predictions. If you see the number of the overhead like these ones, we can create about the new of analysis. The patterns, it could be in a similar positions, but they are in linear, but the kind of linear is in the uniform predictions because they have the similar of average. So this one is called the uniform. Okay, or a stagnant of predictions. And like these ones, we cannot say that, oh, maybe we are in this one's positions, or maybe we cannot conclude about these positions. If you say that these patterns, it could be in like this one's positions. So it's not in a linear. It can could be in a non-linear patterns or in a curve pattern. Okay. This is how we learn about the patterns in a graphical presentations. So how about these ones? This is the kind of non-linear relationships. When you see about the informations like this one in the graphical charts, we can detect this one is maybe in a straight line or linear or in linear. In this case, we can very easy to creating about the graphical chart like this one. This is the pattern of the data. This is how we can show about the life expectancy and gross national per capita as the y-axis and the x-axis. So in this case, we have the difference of regressions. So at the first time, before you analyze your data, please create a patterns and ensure that you have a linear relationships. Then do a regressions. How about if you have the non-linear relationships, you also make a new regressions. Yeah, you can do with the regressions, but the regression is based on the non-linear relationships, like maybe logistic regressions or profit regressions, not a linear regressions. The next ones, we need to learn about the kind of variables named outlier. What is the mean of outlier? Outlier is kind of the observations, the kind of data that falling outside of the general patterns. When you found about the general patterns like the linear positions, the outlier is value out of the average or out of the patterns. So this one maybe make some fail in our interpretations in our data. But sometimes is there are not many, only in a few data for the outliers, they cannot make some significance effect. But if you have lots of outlier, it could be make some wrong predictions. So beware about the outlier of data. Ensure that you only have a few of outliers. Sometimes we cannot exclude or we cannot ignore these outliers. But in the few conditions or in a few kind of data, we can ignore these outlier conditions, but only in a few. But if more than our desirables, the outlier can break our predictions. So your forecasting will be wrong or will be in fails. Okay. Look at these ones. When you can figure out about the scatter plot of salary and the year experience, we can say that the salary, higher salary, is depend on the higher of experience. So as long as your experience is getting high, your salary will be improved. These ones, we can make some linear patterns here. But beware, we have one data that should be classified as the outlier. And the point at the top of right here. This is the one data maybe for the CEO or the directions that getting salary out of the average. If the another people's having a salary no more than 10 millions, this ones, the one people's get a salary in 2 millions. So this kind of data, the one data is included as the outliers. But don't worry about this one because the only one data versus all of this data, this we can ignore these outliers. We can also make with the linear positions. Okay. How about these ones? About the scatter plots like this. Can we assume this is a linear positions or non-linear positions? What do you think, Clinis? Is it linear? Linear or non-linear, Clinis?
I think non-linear, sir. I'm
Non-linear.
not sure.
That's okay, because we cannot make a linear pattern in here. When you say that this is linear, we can make some prediction in here, but we still have lots of data in here and these ones. So in this case, or in this relationships, we also find about we cannot predict these assumptions. So we can say this is unequal variance because a sum of predictions may be violates with the patterns. We can make some wrong predictions because there is a lot of data as containing as the outlier. This one is the outlier, and also this one is the outlier out of the linear pattern. So it's very dangerous if you find about the data with the scatter plot like this ones. You have lots of variability. So you need to categorize maybe in simple blocks, like maybe you can predict between the maybe for the first one blocks, the second blocks, and the third blocks. Yeah. And after this ones, you can conclude that, oh, maybe we have the linear pattern or unlinear patterns. But if you combine all of the data and you got the scatter plot like this, it's very obviously that we can predict with this kind of patterns. Next one is you find about the scatter plot like this between the performance score and the overtime score. What do you think about the patterns, Finish, in this table? Is it linear or non-linear, Finish?
Sir, it is non-linear.
Non-linear, okay. Any answers for Yasin's?
Yes, sir, it is non-linear.
Non-linear, yeah. Because even we can predict with this kind of positions. Look at these ones. You can say that, oh, this is kind of linear. Yeah. But it's getting wrong predictions because the linear only have one patterns, not more than one patterns. So in this case, we have lots of the pair of variables. So in the statisticals, we say that there is no relationships because lots of the pair variables that actually appears in our scatter plots. Okay. The next, we need to predict about the indicator between the linear relationships or not. The first formula that will be easy for predicts is about the correlations that we learn in the 2 weeks with this courses. It's containing about the indicators of the straight line of linear relationships between the pairs of the variables that we actually having the formula like this ones as the mathematical functions, but also we have the numerator for the covariance between the two kind of your variables, the dependent and independence. In most of the statistical analysis, we call the y is the dependent variables, and the x is about the independence variables. To find about the value of your correlations, it should be between 0 and 1. A 0 means there is no correlations in our in the previous courses in the 13th of May. And then the one score or the one value of correlations means there is a perfect correlations, or in analysis, we can say that there is a strong correlations between your variables. It's similar with the opposites of the sign, like the +1 or -1. It's also having the full of correlations. Let's say that the value of 1, it means there's a perfect correlation, even they are in a negative or in a positive. In the negative positions, if we have the -1s, it means that the decreasing of variable x, it means that there is increasing in a variable y. So, and the vice versa about the positive one between the correlation score. And then we need to move about how to predict or analyze in a simple linear regressions. In the simple linear regressions, we only have one single explanatory variables, just only one variable that could be fitted or predicts as the factorial to predict the score of y variables or the dependence variables. To compare about the goodness fit of your data or the good of predictions analysis of your data, we use about the R square, like this ones. The R square means or measure about the goodness of fit models. It ranges between 0 and 1s, and the closer number 1, it means that there is the linear fit. Score close to 1, yeah, I repeat again, score the R square closest to 1, it means there's the better to the linear fit model. This is based on these mathematical functions. So the 1 minus the predictions, it means that there is your goodness fit of data. So this is how we can compare about the another models or another statistical. The models that having the highest R square, like this one. This one is R square. Yeah. It means there is the very good analysis, or they are very predictables between the dependent variable and their explanatory variables. Okay. How about the multiple regressions? While in a single regressions, we only having one explanatory variables. In this case, we have a several explanatory, more than one. For graphically, you need to create with more than one scatter plots. But in a regressions model, you only do with the one mathematical analysis. And the R square between these variables may be vary based on the number of explanatory variables. More explanatory variables, it means that you can create the higher of R square, but less of explanatory variables can decrease your R square of a summary. This is the law in a statistical model between the multiple regressions. You have the several explanatory variables. When you have lots of the explanatory variables or more explanatory variable, it means you're getting more higher in R square. Okay. Between your explanatory variable, it could be scored in a positive value or sometimes in a negative value. But sometimes you only have with this kind of a dummy variables. You only scored between 1 and 0. Maybe like a gender. If male 1, female 0, or and the opposites, female 1 and male 0. Or the interactions variables, we can conclude the interaction variables from the score between x multiply with another x variables. That's kind of multiplications, okay? The interactions variable means that you have the multiplication of variables. Okay, you're welcome, Angelicia. The another one is about the dummy variables. Okay, let's continue about the dummy variables. The dummy variables means you only have the indicators between 1 and 0. This is the indicators. The possibility is only for these two kind of variables or the two kind of score, just like 1 or 0 or 1 and 2, because it means that you need to separate the two kind of categorical variables. For example, like the genders, the quarters, or passing or fail, like that ones. And we can say that this is very simple how to separate your variables. Look at these examples. We have the informations like the educations, the grade, the years of study, the age, the gender, and the job. The job it contains with the two kind of informations, two category, like yes or no. This can is subject to dummy variables. Also with the genders, we only have two value, female or male. So in these parts, we can say that this variables is containing dummy. Like this one is a gender for dummy variables and PC jobs for dummy variables. Because we can convert this one into 1 and 0. This also 1 and 0. Okay. This how we interpret, how we prepare our data before the explorations. For these interactions, it means you have the multiplications between your explanatory variables. So this is how creating about the scatter plots if you have the dummy variables between male and females. So they have a two kind, it's a separations graphical in a scatter plot like this one. Next one, if you have the nonlinear transformations, you need to transform, you need to create with the new informations like make some adjustment using the natural logarithms or the square root or reciprocal informations. This is the statistical way to convert your abnormal conditions between your nonlinear or maybe with the cubicles or the curve of distributions between your variables. So this is very important. You need to transform your variables with the natural of logarithms as the mathematical models, the square roots to eliminate with the minus or the negative positions, and also with the reciprocal models to combine or make some substitutions and eliminations as the mathematical functions that you have learned in the mathematics, maybe in the senior high school. Look at these ones. This is how we can predict with this relationships between the costs and units. As we learn in the general positions, the higher units product or the most of units produce, it will be make some higher costs. This is the law of productions. But In this case, we can create a scatter plot like this ones. So in a similar way, we can say that there is a linear functions between the cost and the units. How about this one? It's named the quadratic relationships. What is the mean of the quadratic relationships? Is based on the informations that we have like these ones. Yeah, this is the multiples informations that could be make some concave distributions. As the statisticals, we can ignore about the negative and positive or also negative behaviors because there is a concave of the distributions. So the residuals will be difference between the linear or the quadratic relationships. Sometimes we are very rare to use these informations like for predictions because it could be make some differences. So how to transform about your nonlinear functions? If you have nonlinear data, the one thing that you need to learn about transformation is about the logarithmic transformations. In the statistical or mathematical models, we can transform with the curve distribution like this ones. With a logarithmic transformations, this is a curve will become a linear or mostly like a linear, not in a few linear. After you transform your data using the logarithmic transformations. So after you create your data into the, yeah, this is a similar way or closest to the linear of the scatter plot, it means that you can do with your transformations because our base in the regression model is based on the linear positions. So while you found about the curve distributions, the first thing that you need to do is transform with the logarithmic functions or logarithmic transformations. And then you can over your curve or logarithmic positions into linear functions. There is the first part about the relationships using the regressions analysis. Any questions so far for you for the Hyacinths, Oliver, Glynis, or Citabel and Venice?
None, sir.
Okay, thank you for responding, Glynis. Thank you for responding, Olivers. Yeah. Next, we are continuing about the forecasting in the time series analysis. Yeah, I can read your message, Citabel. Yeah, thank you for responding. How about the forecasting? Yeah, the forecasting is a very difficult task because we need to predict. Sometimes we have lots of data. Sometimes we are in the scarcity of data. So it could be in the short data or in the long run of data. The predictions or the forecasting using the short data and the long run of data, it could be different. So what we can predict in the short positions and long positions may be in a difference. So we need to analyze about your patterns. So the first thing that we need to learn about the scatter plots. Like the previous materials, we need to predict the first time you need to creating some plots. So after then, you can make some prediction, you can make some historical patterns, you can creating that there is, you can find about the outlier or you can just to make new of the predictions. Only after you have to plot or graph your uh, analysis using the plot analysis. And then for the forecasting methods, we only have three kind of the separations between the group. Sometimes we can make forecasts from the judgmental methods for the best our knowledge. And then as the statistical models, we have the extrapolations or time series methods based on the time series evidence. And then the last one is for very advanced model in statistical. We say that econometric or the causal methods, because they are very full of knowledge or the previous factors to predict another ones or to create some forecasting after controlling so many informations that we need to know. But this one is based on our decisions, the research decisions. It should be in a non-quantitative, and also they are in a quantitative predictions. Okay. Let's start about the extrapolation model. This kind of the name of time series analysis. We can learning in any kind of the mode, like the trend-based analysis, for the autoregressive analysis, the moving average, and the exponential of smoothings. The complex model is very excellent in here because we can comparing lots of data using the R square, like the previous informations. You can combine where is the R square? It's closest to score number ones. And also with the econometric models, because we also use as the econometricians, we use these models. This kind of the causal models can forecast in a time series conditions or the cross sections condition, or sometimes we are do in the combination of that. We call the panel data series. So the econometric model is the best models or the highest good model to present about the mathematical challenge between your analysis. Okay, how we can combine our forecasting or our predictions? The reason is simple, because sometimes our predictions or forecasting is containing with some error of data. What kind of error of data? It could be containing about the outlier or maybe with the mistake of data. So it's affected to our forecasting methods or our forecasting analysis. Look at like these ones. We can say that the first part to create about the forecasting analysis, if we can know about the trend of positions. In this ones, we have the linear trend, and this one is exponential trend, and another one is about the S-shaped trends. When you are in the linear trend, it's very easy to predict about your forecastings. But if you are in the exponential trend, sometimes it's not easy. It could happen too in the S-shaped trends, because they have lots of factors that could be make some difference analysis or different value while we are combining about the axis between X and the T in here. The next informations about the problems in the time series data is sometimes we have the seasonal problems. The seasonal problem is containing about the same of seasonal patterns that could be repeat in every periods. Let's say that maybe in every years or every week or every month. Look at this one. It is a seasonal components. Like after up, there is down, up, and then down. After then you can go up, and after then you can go down. Just like that. That's a same seasonal patterns. Up, down, down, up, down, up, down. This one only the seasonals, but sometimes we found about the seasonal with a trend. This also find about the same seasonal patterns, the up, down, up, down, up, down, up, down, but it's also in increased trend. They are increasing value, the increasing number or the increasing patterns. I hope you know the differences between the seasonal and seasonal with trend. This one is there is no predictions, only for the seasonals. And this one's the also seasonals in the curve of positions, but also they are growing in a positive of trends. The next one is a cyclic components. A cyclic components, it's also similar with the cycles or with the seasonals, but they have the effective in a different time conditions. Look at these ones when we have the cyclic component only. We also find after downs, they can going up, and after downs, they can going down. But the period, it could be different. We can say that this one is a difference period. When we going down, going up, going down, and going up, down again, sometimes in going up again, they are in a different times, not exactly similar like the seasonals. This is the problem about the cycles. We doesn't know how long the cycles. It should be in a short cycle or could be in a long cycles. In this case, we also have the positive trendings, but we have the maybe closest to the seasonal pattern. We also the up and down. But these ones, we have the different time. It's very long to going up, it's short to going down, and very long to going up again, short to going down, short to going up, short to going down. This is the kind of cyclical component that we cannot predict easily when we can do in these patterns. How about this one? This one is very, very unpredictable. So in scientists, we can show that this is a randoms model or noise model because it should be in irregular patterns. Sometimes zigzag, sometimes in a linear, sometimes in a curve. But yes, we can predict anymore. It is very easy that we can say this is only unpredictable component. So be careful when you found this data with the series like this one. It's very uncertain for predictions. Okay. Next, how we can compare about the accuracy of models. The forecast error is maybe contained in every models, but we can comparisons with this one, the mathematical process like this one. Sometimes we can use the mean absolute error, root mean square error, or mean absolute percentage of error. Which one you can do? It's you can choose with the best one that you can do or presents in your data. What is the best conditions that interprets as the best of the accuracy? The more accurate model is containing the few or a small of value or small numbers of this error. Because we talk about the error, the small value of error, it means that you have the greatest percentage of accuracy. So in the opposites of definitions, you need to find about the lowest value for error, so you can find or you can getting the highest accuracy of your modeling. Next is test about the randomness or the randoms model or random data that containing in your data analysis. Please remind that our data is contained about the fit value and a residual value. The residual value is similar to error. The error one is also contained is any kind of data. Don't believe 100% with your data. You need to think that your data may have the possibility of error, even they are in a 1%, or maybe in the smallest of 1%, or maximum in a 10 or 15%. So any kind of data is containing an error, regardless the score, regardless the value. Look at these ones, we can say that this is non-random patterns. The random patterns, we cannot predict about the graphicals or the inflations of your data. But in this case, we can predict your patterns. So we call non-random patterns. How to do about the randomness of data? We can do with the run test in a statistical model. The run test is kind of quantitative methods, and this is the way how we test about the randomness of data. In the formal of the test, the run, it means that your data is not in a simple way to predict, not a simple way to predict like the average of the score, the median value, or run in the series, in the time series of data. In the regressions, also containing about the autocorrelations. What is the meaning of autocorrelation? It means that in every independence variables or explanatory variable is containing a strong relationship. We know between the dependent or target variables and explanatory variables need to have a strong relationships, but it's between independent or explanatory and the target variable or dependent. But between the explanatory variables, it should be no strong correlations because it's very danger if you have strong correlations between your explanatory. It could be measured with the same formula, or it should be have the similar trend or a similar following tendencies. So we cannot predict with the similar conditions. It should be having a highest accuracy, 100% of accuracy. So we cannot make some predictions anymore because it's quite predictly with the another of patterns. So be careful if you have the autocorrelations problem between your explanatory variables. After checking about the informal conditions like your descriptions of your data, your trend analysis, your patterns with the scatter plot, and checking with the autocorrelations, you can do with your regression-based trend analysis. So it based on the linear models. So we need to ensure that you always transform with the non-linear informations into logarithmic mathematical functions, and then they are similar or closely to linear model, and then you can do with your regressions analysis. Okay, let's check about our data. In our data, we can predict with this. Let's say we have the informations from questionnaires data. Okay. From this questionnaires data, we found the informations like this one. We have data for the age, the salary, and the children's. Let's say that the age, the children's, and the salary, and also the opinions. I move here. Okay. Let's say that the salary is a dependence variables, and the age, children, and opinion is an explanatory variables. Okay. In this case, we can use both the data analysis using regressions. Please choose with these ones, regression analysis. These ones from data analysis, you can choose with the regressions. You can input your y-axis like this one, the salary. It's only 30 of data, and the x variables or explanatory variables is based on the age, children, and opinions. We do with the labels and the first row. And let's say that we have it. This is the confidence levels that we learned in previous two meetings. If you have 95% of confidence levels, it means that you believe your data is containing 5% of error. But if you feel that your data is only have 1% of error, you can change into 99%. Okay, I hope it's very refreshing about your materials. After that, we can make some probability plots here or line fit plots. Check your output here. Okay, and we can do with this analysis. Okay, this is our analysis. We can predict about the number of a salary. The salary, it could be predicted with these informations for the age, the children, and opinion. From this p-value, we found that age is very dominant in here. The age is having a strong, is a moderate relationships between the age to the salary. We have the find of R square here. The discord, it means that we have 11 and 71%. This is the standard of error. It means that there is a high error in our data because we only have a 30 data to be predict in here. This one is with the data that should be analyzed in our data analysis. Okay, how about the scatter plots? The scatter plot is consists of in here. Yeah, this is the normal probability plot. This is the line plot. We don't do this one. We can delete, but this one is the normal probability plot. This is the plot between the salary and the percentiles of your data. So if you can create about the trend line, this one. Okay, this is the format of trend line. If you think that this is linear, you can find about these ones, the informations of the linear analysis. But if you think, oh, maybe it's a difference, like this one, exponentials, it's not. Like this one, logarithmic, it's no. It's a polynomial, it's no. It's the powers, no. Moving average, yeah, it may be in a moving average. It's very quiet to these positions. So we can find about the trend line. The scatter plot could be in a linear, but with the exceptions. The exception is we found a two outlier here. This kind of outlier, okay? 95 and 98.3. If you believe you have a linear trend like this one, you need to ignore or you need to exclude the two of outliers. Okay. But if you think that they are in a moving average positions, we can include all of the data, include your outlier. So we can find that, oh, there is non-linear. What kind of non-linear? It's kind of a moving average. It's not in a logarithmic. It's different. It's not in a polynomial. It's different. It's not in a powers or exponentials. So it should be different. It's very similar with the moving average. Okay, like this ones. You can do with your exercise with your personal of your data. So in this case, I close the sessions for the regression analysis. And after this parts, you can do with your personal analysis. Uh, you can do with our previous data, like these ones. You can do with this three kind of data, data number 1, data number 2, or data number 3, or you can use with your personal data. If you have your independence data, it's offers to you, it's very open to you. You can do, you can make it as your exercise. This point is about how you exercise with your analytical skills doing with regression analysis. So after that, you can upload your exercise here. So I can check that you are very acceptable or you are very familiar with our regressions analysis. I think it's very simple to do with your we are working on regression analysis only. Yeah, this is to answer about the Oliver questions. You only do with the regressions analysis only. We need to check about step by step for your data analytics. We are starting with this data descriptive and you do completely. The second point we do with the inference, like the correlations, making some plots, and you also do with some crate exercise. And for now, we are doing in regressions analysis. For next meeting, we will comparing about the multiples regressions, and also we continuing about the advanced model of regressions analysis. I think it's uh, for the preparations for the next meeting and our two next of year meetings. I think that's all that you need to learn, or I need to inform you, trying lessons for you for today. If you have any questions, you can ask me here in this time, or maybe you can ask for me using the emails, or we can do with your personal analysis. Submit your analytical process, and then you can ask again in the next meetings. Thank you for coming, and thank you for learning together for this day. I hope you are very in a good conditions, because we still have 3 meetings before the final test of this course. Okay, before I close the sessions, any questions from you so far? Is
None,
everything
sir.
okay?
Thank you so much.
Yeah, thank you for responding. Yeah. Everyone is doesn't have any questions. I think that you are having a good knowledge, or you have a good positions to learn with the data analytics. Thank you for coming for today, and see you next week.
Thank you, sir.
You're
Thank you, sir.
Thank you,
welcome.
sir.